Hello everyone. I hope you all are doing good. You all are fit and fine. Your studies are going in a smooth manner. I am your educator Nidhi Dua and I teaches you chemistry at this platform GurMantra Shiksha Ka Granth. So I warmly welcomes you to our YouTube channel GurMantra. So guys, this is our chemistry syllabus for GATE exam. This is our section 1 named atomic structure and periodicity. In previous lectures, we have completed atomic structure, and in this lecture, I am going to explain about the trends in periodic properties. So basically guys, till now we have covered these topics, and in this lecture, we are going to start about the trends. So basically guys, trends means in periodic table is designed in such a way that you will get some specific patterns in the properties of chemical elements that reveals the periodic table of elements. Okay, so basically the organization of periodic table can be used to derive relationships between various element properties and also to predict the chemical properties and behaviors of undiscovered or newly synthesized elements. So the major periodic trends that we are going to study are electronegativity, Z effective, atomic radius, electron affinity, and so on. So the very first periodic trend that we are going to start is effective nuclear charge. So basically, effective nuclear charge is the attractive force between positive charge of nucleus and electrons of valence shell, electrons of outermost shell. And this effective nuclear charge is also known as Z effective. This is very important to note that the value of Z effective is always less than the total number of positive charge present in a nucleus. I repeat, value of Z effective always comes to be very less than the total number of protons present in the nucleus. So this is due to the reason of shielding effect. Z effective always come less due to the shielding effect, and this shielding effect is also known as atomic shielding or screening effect. Basically, shielding effect is the attractive force between electron and nucleus. All the electrons and nucleus shows a force, and this force is known as your shielding effect. This shielding effect causes the decrement in Z effective. As you can see here, this is the statement. Z effective is always less than the total number of protons present in a nucleus due to shielding effect. So basically, effective nuclear charge, Z effective, is behind all the periodic table trends. That's why we have started this periodic trend very first. The Z effective experienced by electron is also called as core charge. You have to remember this. Z effective of an electron is also known as core charge. So basically, if we want to calculate the value of Z effective, then the formula comes out to be Z minus sigma, where Z defines the nuclear charge and sigma defines the shielding constant, the screening effect constant. The order in which the sigma follows is the screening effect of S subshell is very much high than the subsequent subshells, and the screening constant for D and F block elements is very low because of their larger size and their diffused shape. Also, this is very important formula that Z effective is directly proportional to positive charge and inversely proportional to negative charge, which means if you increase the positive charge, then the value of Z effective also increases, while if you increase the value of negative charge, the value of Z effective will decreases, and vice versa. This formula is only applicable for different ions of an element. This Z effective formula is only applicable for different ions of an element or for isoelectronic species. Here, isoelectronic species means the elements which has the same number of electrons present in their shell. So as you can see, this is an example. The very first example is of n plus 3, n and n minus 3. You have to give the order of Z effective. Now, as you know, as we have seen in the previous slide, this formula that Z effective is directly proportional to positive charge, which means as you increase the positive charge, the value of Z effective will also increases. Therefore, here comes the order that the value of n plus 3 is much greater than the value of n minus 3 because Z effective is directly proportional to positive charge and inversely proportional to negative charge. Now in next example, we have the order that is beryllium plus 2 has the maximum Z effective. Now when you have given a negative charge and a positive charge in a single question, then you have to follow this trend, which means Z effective will increases when the positive charge increases. So the order comes this, and the order is n minus 3 is less than O minus 2 and O minus 2 is less than F minus and it is less than Na plus, and maximum comes out to be Mg plus 2. Now this slide is also very important. You have to remember this for normal representative elements, and you know it very well. Normal elements are your first A group, second A group and P block elements. First A group and second A group are also known as S block elements, and P block elements are group number 13 to group number 18. When you move along a period, the value of Z effective increases by 0.65 in case of normal elements, in case of S block elements and in case of P block elements. The value of Z effective increases by 0.65. While for the elements of transition elements, for the D block element, along the period Z effective increases by 1.5. I repeat, you have to remember these values because this will help you to solve the questions. Now, as you can see, this is a very first question. Which pair represents the increment in Z effective by 0.65? You have to tell the order, you have to tell which group is correct, which pair of elements is correct in case of if the Z effective increases by 0.65. So here I would suggest please pause your video and solve this question and think about the reason. Okay guys, so let's see the solution. So number one option is your C2O. So first of all, you need to remember the periodic table to solve these types of question. So basically, as you can see, the carbon atom is present in group number 14 and oxygen atom is present in group number 16. And when you move along the period from carbon to oxygen, the Z effective value will increases. But here comes the nitrogen in between carbon and oxygen. For increment in the period by 0.65, there should be a subsequent elements, which means the elements should be present side by side. So the option 1 comes out to be wrong. Next option is Ti to Cr. Let's see. Ti is present in the group number 4 and Cr is present in the group number 6 and in period number 4. When we move from Ti to Cr, the value of Z effective will increase, but not by the factor of 0.65. The factor will be greater than the 0.65 because V comes out to be in between Ti and Cr. So this option is also wrong. Next option is from sodium to potassium. As you can see, sodium and potassium both lies in a group number 1. So this option is also wrong, because we always talk about the Z effective value increases along the period, not in the group. So this is also the wrong option. Now the option left out is to be Cu plus Zn. So let's see. Cu and Zn. Cu lies in the period number 4 and Zn also lies in the period number 4, and when you move along the period 4 Cu to Zn, this value should increases. The value of Z effective should increases by the factor of 0.65. So the right answer is Cu to Zn. I hope guys you are now cleared about this table. Okay, let's move on to the further slide. Next topic is next periodic trend is atomic size and atomic radius. So basically atomic size and atomic radius is the average distance of outermost electron from the center of nucleus. This atomic radius is of four types. It can be, number one is your covalent radius. So basically covalent radius are found in the single bonded atoms. These bonded atoms could be homo atoms or hetero atoms. Homo means similar kind of atoms and hetero means different kind of atoms. So basically this is the half of internuclear distance between two single bonded atoms. So this is the formula to calculate the average distance or radius between two atoms. So guys, this formula was given by Stenson and Shoemaker, and this formula is known as Shoemaker and Stenson formula. This formula is DAB is equals to RA plus RB minus 0.09 into difference of electronegativity between two elements. So basically you have given two elements, two atoms. One is your DA and second is your DB. So basically this formula is applicable for heteroatomic molecules. As you can see, heteroatomic molecules are made up of molecule A and molecule B. So for understand this formula, let's take an example. You have given the distance between hydrogen and hydrogen atom is 74 picometer. Now as you can see, this is the diameter or distance. You have to calculate the radius, and you know it very well, the relationship between diameter and radius. Radius is half of the diameter. So we have calculated the radius of hydrogen by simply dividing the diameter by 2. So we have got the 37 picometer. And next is for D is equals to Cl, and Cl the given is 198 picometer. So we have also calculated the radius for chlorine atom, that comes out to be 99 picometer with the help of dividing by 2. Now we have to calculate the distance between hydrogen and Cl. We have to calculate the radius of hydrogen and Cl. So basically guys, as you know the formula, RCl is equals to RH plus RCl minus 9 into difference of their electronegativity. It is very important to note that if radius A and radius B are given in picometer, then you can take this 0.09 as 9. I repeat, if radius A and radius B are given in the unit of picometer, you can use this 0.09 as 9. As you can see here in this example, picometer unit is used. So we have taken 9, and electronegativity of different ions value of electronegativity of different ions will be given to in the question. So basically we have put the value in the above equation, that is RH we have calculated, it is 37 picometer, RCl as 99 and minus 9 into 3 minus 2.91. I repeat, electronegativity values will be given in the question, and when we solve it, we have got the result as 128 picometer. Next radius is of type of metallic radius. Metallic radius is found in the metal atoms, and this is also the half of internuclear distance between two nearest metal atoms. Number third is van der Waals radius, and van der Waals radius can only exist in solids and noble gases. Next one is ionic radius. Ionic radius always exists in different ions of an element. Now this is very important slide. You have to remember all the points of this slide. Number 1 point is radius of van der Waals. Van der Waals radius is always greater than the metallic radius and covalent radius. Always. Second point is R van der Waals is equals to the twice of covalent radius. Number third is in case of non-metals, covalent and van der Waals radius is possible. Both radiuses are possible. In case of metals, covalent and metallic radius is possible. You have to remember the points. Now, factors affecting atomic size or atomic radius. Number 1 point is number of shell, which means when you increases the number of shell, the radius will increase and the overall size will increase. I repeat, when you increases the number of shell, when in a particular atom number of shell increases, then their atomic radius must be increases. Second point is Z effective. If the value of Z effective increases, then the size must be decreases, which means Z effective and size has a inverse relationship between them. Z effective is inversely proportional to the size. Next is variation of atomic radius in periodic table. Number 1 point is in a period, number of shell remain constant. You have to remember this. When you move from left to right in a periodic table along in a period, number of shell remains constant. Therefore, Z effective values increases and size decreases. As you know, Z effective and size has an inverse relationship. Therefore, when the value of Z effective increases along the period, the value of size decreases. Now, in case of group, when you move from top to bottom along a group, number of shell increases, therefore size also increases. Now, this is also very important. You have to remember these points, these 3 points. These points are the maximum atomic radius in a period. Maximum atomic radius in a period is of noble gases. Second one is maximum covalent radius in a period. The maximum covalent radius in a period is of alkyl metals. Alkyl metals means first A group. Number third is minimum atomic radius, and minimum atomic radius in a period is for halogens. Group 17 elements. Okay. So basically this is the important formula to determine the size. So basically size is directly proportional to negative charge and inversely proportional to positive charge. As you know, Z effective and size has an inverse relationship. Therefore, the relationship of Z effective between charges is also inverse here in case of size. If you have given this kind of order you have been asked about the order of size, then you have to follow this trend, which means the size of negative ion is always greater than the positive ion, because you know it very well, size is directly proportional to negative charge. So this is the important example in which we have given the different ions of oxygen atom. So and we have been asked about the order of their size. So basically O minus has the maximum size while O positive ion has the minimum size due to this relationship. In next example, as you know, we have asked about the order of size. So basically the order of size will follow this trend and the size of Si plus 4 will be smaller because size is inversely proportional to the positive charge. As you increases the positive charge, the size will decreases. Now guys, in next 2 slides we are going to discuss the important orders. You will get all the important orders, you will get all the exceptions here in these 2 slides. So I would request, please do follow these slides in your preparation. So number 1 order for atomic radius is in case of second period. So basically when you move along the second period, the size should be decreased up to fluorine atom due to the Z effective increment, and as you know, Z effective and size has a inverse relationship. Therefore, when along the period Z effective increases, size decreases. But in case of fluorine and neon has the larger size than fluorine atom due to the van der Waals radius. Guys, this is inorganic chemistry and exceptions are always there in inorganic chemistry. So you have to learn all these points, why this size is increasing, why this size is decreasing. So in next point, in transition element, in case of transition element, size decreases up to iron because the value of Z is always greater than the sigma. The value of nuclear charge comes out to be greater than the screening constant. But in case of iron and nickel, the value of Z comes out to be similar to the sigma. And in case of nickel and zinc, value of Z is always less than the sigma. Therefore, zinc has a maximum size. You have to learn this order. This is very important order. Third point, but in case of metallic radius, chromium has the less than manganese. But in case of metallic radius, chromium has less radius than the manganese. This order was basically for covalent radius and this is for the metallic radius. All order will remain constant in case of metallic radius, but the chromium radius will decreases in case of metallic radius as compared to manganese. This is also very important to note that. Number third point is order of atomic radius of group first A and second A. If you have been asked about the relationship of atomic radius between first A and second A, you have to follow this trend in which beryllium has the least atomic size while cesium has the greatest atomic size. You have to remember this point. In point number 4, in group number 13, aluminium and gallium has almost constant size, has almost equal size, which is due to the transition contraction. And in indium and thallium, these both have also equal size due to lanthanoid contraction. And the order comes out to be aluminium has equals to the or greater than gallium, while thallium has greater or equal to the indium. This is talking about atomic radius. In group 4 to 12, which means in D block elements, 3D series has always less than the 4D series, and 4D series, 5D series and 6D series have equivalent radius or equivalent atomic size. I hope guys you are now cleared about these two trends. We will solve further questions on these trends in the next video. But for now, I would suggest please remember this slide and this slide because these are the most important orders of atomic radius. In these two slides, we have covered most of the exceptions which has the most probability to asked in an exam. And I repeat, in inorganic chemistry, you have to learn the things. So you have to revise them on the daily basis. Now, in case you are new here, you are new at our platform GurMantra Shiksha Ka Granth, please do like, share and subscribe to our channel. You can also join our Telegram channel for further new updates about different exams. You can also get our notes on this channel. You can also join our Facebook page named GurMantra Shiksha Ka Granth, and for further queries you can mail us on tanejanehaofficial@gmail.com, and you can also contact us on the given number. Thank you very much guys. I hope you liked the video.